All right, lucky you, you get to be a part of my entry test today where I'm asking students to determine if something is arithmetic, linear, quadratic, or neither. All right, so what we're gonna be doing is drawing the fifth figure. Here we got figure 1, figure 2, figure 3, 4, and we have to draw the fifth. And then we need to determine, are we dealing with something that has a constant rate of change or something that is quadratic, or maybe neither. All right, so here we go. First and foremost, I need to look at my images. We've got a dot, then we have 1, 2, 3 dots, then we have 1, 2, 3, 4, 5, 6 dots. Okay, so I can tell right now I'm not gonna be growing at a consistent rate, but I do need to figure out the pattern. It looks like, the way I see it, that dot goes there and then we added 2 below. This whole image goes here and then we added 3 below. So we're kind of just adding the bottom layer each and every time. That's what the way I see it, at least. So what I'm gonna do here is I'm gonna say 1, 2, 3, 4. Now I need to make a 1, 2, 3, 4, 5. The next row up has one less than the row above. So 5, 4, 3, 2, 1. Okay, most kids are able to come up with the image, but then answering this question is where they get stuck. So let me explain to you how I would determine if something is quadratic, which we just started our quadratic unit. I'm asking kids to determine through different representations. Right, here's just images, right? Diagrams. It can be given as a table, it can be given as a graph. I like to convert something like this into a table. And this is what I would recommend my students do. Okay, so we make a table of values. Our X is just going to be what's the diagram, which one is it? Okay, so 1, 2, 3, 4, and 5. And then we're going to say how many dots we have in each one. Okay, so I've got 1 dot in the first one, I have 3 in the second, then I bump it all the way up to 6, then we go 4, 5, 6, 7, 8, 9, 10, and 5, 9, 10, 11, 12, 13, 14, 15 total. So now what I've done is I've created a diagram or a pattern, okay, that was given just as a picture, and I've now turned it into a table of values. Quadratics, how do we determine if something is quadratic or not? It all has to do with the second difference. So we're gonna find our first difference, and then we're gonna go one more out from that and find our second difference. And if we have consistency within our second difference, we know we're dealing with a quadratic. So 1 to 3, I'm going up 2. 3 to 6, I'm going up 3. 6 to 10, going up 4. 10 to 15, up 5. So this right away tells me it's not arithmetic. You can scratch that out. It's not going to be a linear problem. It does not have a constant rate of change right away. But if we go to our second difference, 2 to 3 is +1, 3 to 4 is +1, and 4 to 5 is +1. We see consistency in our second difference. Therefore, this would be a quadratic. Hopefully this makes sense. It's all about finding the second difference and hoping that it is consistent. Study hard and good luck on your upcoming test.